So let's check the history of the .NET framework. So in early 2000, that is in 2002, the first version of the .NET framework, that is 1.0, with C# first version has been introduced by the Microsoft with some additional features like .NET CLR, the .NET base class libraries, ASP.NET, and most importantly, the first version of the Visual Studio.NET. As we are aware, .NET framework is a platform-dependent technology. What does it mean? So whatever the applications created under this framework can support only the Windows operating system and not Mac OS and Linux operating system. So the next version 2.0 has been introduced by Microsoft in 2005 with C# 2, and the features included are partial classes, nullable types, anonymous methods, and data tables. In 2006, .NET Framework 3.0 has been introduced by Microsoft with some additional features: Windows Presentation Foundation, Windows Communication Foundation, and Windows Workflow Foundations. These technologies are used to create desktop applications. In 2007, next version has been introduced, that is 3.5 with C# 3.0, and the features were included are Visual Studio 2008, extension methods, link queue, and entity framework. In 2010, 4.0 with C# 4.0 has been introduced by the Microsoft, and the features were included are parallel link queue, task parallel library, etc. In 2012, .NET Framework 4.5 has been introduced with C# 5.0, and the features were included are improvements in garbage collection, WPF enhancements, and improved support for HTTP protocol. So in 2015, .NET Framework 4.6 with C# 6.0 were released by Microsoft, and the features are C# 6, just-in-time compiler, and the Visual Studio 2015. So in 2016, there are lots of technologies available in the market which supports multiple platforms like Mac OS, Linux, and Windows operating systems, and those technologies are open source. So to compete with them, Microsoft has also decided to launch one technology which is cross-platform and open source. So no any kind of licensing is required to create the applications. So Microsoft has decided to launch .NET Core 1.0 with C# 7.0. So the features were included are ASP.NET Core for web application development. So in 2017, .NET Framework 4.7 and as well as .NET Core 2.0 has been introduced by the Microsoft, and the features were added object cache extensibility, improved transport layer security, that is TLS. And in Core 2.0, Visual Studio 2017 has been released with ARM support for IoT scenarios, improved performance and scalability, including support for generic types like span-T and memory types. In 2019, 4.8 version of .NET Framework is introduced with C# 8.0, and also next version of .NET Core, that is 3.0, has been introduced by the Microsoft, and the features were added by Microsoft are: it added the support for Windows desktop applications and Windows Presentation Foundation and Windows Forms and HTTP 2 support. In 2020, .NET 5 has been introduced by Microsoft with C# 9.0. So instead of calling .NET Core, Microsoft had decided to call it simple .NET instead of .NET Core, and the features added are C# 9. In 2021, .NET 6 has been introduced by Microsoft, and the features were added are minimal APIs for ASP.NET Core development, top-level statements, as well as file scope namespaces. In 2022, next version of .NET, that is 7, has been introduced with C# 11, and the features added are native AOT, significant performance improvements, including faster startup and execution. So in 2023, the last version of the .NET 8 has been introduced by the Microsoft with C# 12. So we are going to discuss each feature further in tutorial. So let's discuss them now. So let's discuss each version in detail. So the first version of the .NET framework was released on February 12th, 2002, and it has been a Windows only. It means that it supports only the operating systems which was developed by the Microsoft. Those are Windows operating systems like Windows 98, Windows ME, NT 4.0, and Windows XP. It does not support other operating systems like Mac OS and Linux. The .NET Framework 1.0 introduced the .NET CLR, the .NET Base Class Libraries, ASP.NET, and most importantly, the first version of the Visual Studio.NET. Visual Studio.NET is the editor for developer to write the code, debug the code, and build the applications like console applications, web applications, and Windows applications. So the next version is 2.0, which was released at the same time as Visual Studio 2005 on November 7th, 2005. The most notable new C# features included partial classes, nullable types, anonymous methods, and data tables. And the biggest addition to the .NET was introduction of the Win forms. So the next version was 3.0, which was released on November 6, 2006. And it introduced Windows Presentation Foundation, Windows Communication Foundation, Windows Workflow Foundations. So these technologies are used to create the desktop applications. And Windows Communication Foundation is used to create the web services or Windows services. The next version was 3.5, was released in November 19th, 2007, and brought meaningful improvements and new features for existing technologies such as WPF and WCF. And most notably, the new release of Visual Studio 2008, extension methods, link queue, and entity framework, these features has been introduced in 3.5. The next version was 4.0, which was released on April 12th, 2010. It was a massively improved and enhanced version. It also came with the Visual Studio 2010 release. The most notable new technologies introduced were parallel link queue, task parallel library, and the introduction of the begin data type. .NET Framework 4.5 was released on August 15th, 2012, together with Visual Studio 2012. It brought built-in support for async await to handle asynchronous operations, improvements in garbage collection, WPF enhancement, improved support for HTTP, and including WebSockets and better HTTP handling. 4.6 was released in 2015 together with Visual Studio 2015. It added the just-in-time compiler. The just-in-time compiler is used to convert Microsoft Intermediate Language code to the native code. So what is Microsoft Intermediate Language? So each programming language has its own compiler. When any compiler compiles the code, it gets converted into the Microsoft Intermediate Language for interoperability purpose. So both programming languages can communicate with each other that are supporting .NET Framework. So the next version is 4.7, was released on April 15, 2017, together with Visual Studio 2017. It included a new features like object cache extensibility or improved transport layer security. The next version was 4.8, which was released in 2019 and was the last release of .NET Framework era. It included the release of Visual Studio 2019. After that, any new version has released by Microsoft of .NET Framework. It included improvements for the JIT compiler and added anti-malware scanning for all assemblies for security purpose. .NET Framework 4.8.1 was released in 2022. After that, .NET Core is introduced by the Microsoft instead of .NET Framework to get into the open source technology and to support multiple platforms like other operating systems like Mac OS and Linux operating system. So the .NET Framework was highly successful for over 15 years with an increasing number of developers and companies adopting its programming language to build the applications. However, it is closely tied to the Windows operating system. So as we already aware, .NET framework was tightly coupled with Windows operating systems only and cannot execute those applications on Linux and other operating systems. So which limits applications running on the .NET frameworks to Windows only. Additionally, the release cycle is dependent on Windows updates. In modern software development, there is a need for faster development cycles and more frequent incremental changes. Another important trend is shift towards the open source developer platform. So as we have already discussed this in previous slide. So due to licensing constraints, open sourcing the .NET framework was not feasible as it is tightly integrated with Windows only. Over time, these limitations, particularly being restricted to Windows, became more problematic. This is where .NET Core steps in. .NET Core is a free open source platform built for cross-platform development. It is independent of Windows, allowing developers to use Linux, Mac OS, and Windows to create the applications on .NET Core. These features make .NET Core a strong option for cloud-native development. Then the next version of the core is 1.0, which was announced in 2014 and released on 2016, and also brought us C#6 with some additional features. So ASP.NET Core, a web application development framework, was the first new technology built on top of .NET Core and released with .NET Core 1.0. So the next version was 2.0, which was released a year later on August 14th, 2017, a few months after the .NET Framework 4.7 and Visual Studio 2017 releases. It also brought us C#7 with additional features. The major features were ARM support for IoT scenarios, improved performance and scalability, including support for the span T and memory T. These are the generic types. So the .NET Core 3.0 was released 2 years later on September 23rd, 2019, a few months after the final .NET Framework version 4.8. It also brought C#8. It added support for Windows desktop application development with Windows Presentation Foundation and WinForms and HTTP2 support. So the next version is 3.1, which was a long-term support release that was highly adopted in the community, was released on December 3rd, 2019. Starting with .NET Core 3.1, there was a massive shift towards developing applications on the new .NET Core instead of old .NET Framework. Improved features, C#8 enhancements, Windows Forms, WPF improvements, and new JSON serialization APIs. So after .NET Core 3.1, Microsoft has decided to call it as a simple .NET instead of .NET Core. So the .NET 5 was released on November 10th, 2020. The jump from version 3 to 5 was done to prevent the mixing of the .NET framework with .NET 4. .NET 5 also brought up C#9. It's also the version where .NET Core was renamed to just .NET, as we have already discussed. Also, Blazor server was released with .NET 5. So the next version was .NET 6, which was released in 2021. It was the first long-term support release after the rename to .NET. It also came with C#10 with some additional features like .NET Hot Reload, a technology that massively speeds up the development feedback cycle. So the minimal APIs for ASP.NET Core development, top-level statements, as well as file scope namespaces were introduced in .NET 6. So the next version was .NET 7, which is officially launched on November 8, 2022. It brought significant performance improvements, including faster startup and execution. It also came with C#11. Key features included native AOT, enhanced minimal APIs, cloud native services, and .NET MAU, that is multi-platform app UI for building cross-platform apps. So the .NET 7 continues to focus on performance, simplicity, and cloud integration. So the next version was .NET 8, which was the last version of the .NET 8, which was released by the Microsoft in 2023. It also came with C#12 and with some additional features. So let's discuss the components of the .NET framework. So the first component is CLS, that is Common Language Specification. So the CLS is a set of rules that ensures code written in any programming languages can work together seamlessly within the .NET framework. So the next component is Common Language Runtime, which is also called as CLR. So CLR, it is a brain of the .NET framework and perform different tasks like execution of the program, manage security, etc. So we can discuss in detail further for each component. So the next component is base class library, which is also called as BCL. So in real life scenario, we have to perform some string manipulations. We have to convert the date time into the another format. For this purpose, .NET Framework provided some inbuilt classes, which are also called as BCL class libraries. So the next component is framework class library, which is also called as FCL. It is a superset of BCL. It means that it contains all the classes from BCL and some additional classes to perform tasks like input-output operations on file and database operations, etc. So the final component of the .NET framework is Common Type System, which is also called as CTS. So the Common Type System makes sure that different .NET languages like C# and VB.NET, when gets compiled, then it's converted into the common type, which is also called as MSI, that is Microsoft Intermediate Language. So those languages which are compatible with the .NET framework, when gets compiled, it will get automatically converted into the common format, which is called as MSI. So let's check the component of the .NET framework. So the bottom layer is operating system, then common language infrastructure, which is also called as CLI. Then the next layer is common language runtime, which is the brain of the .NET framework, which performs different tasks like garbage collection, security, and execution of the application. Then the next layer is ADO.NET and .NET remoting libraries. Then after that, ASP.NET, WinForms, and Console, these libraries comes into the picture. These libraries are used to create web applications, desktop applications, and console applications. So the next layer is FCL, that is .NET Framework Class Library. Then the next is Common Type System, which is CTS. And the next layer is Common Language Specification, that is CLS. And the final layer is programming languages like VB.NET, C#, and JavaScript. To become a .NET Framework compatible language, then that programming language need to follow all set of rules which are defined in Common Language Specification and Common Type System. Then only that programming language become .NET compatible language. So let's discuss each component in detail. So the first component is framework class library, which is also called as FCL. So the FCL is a superset of BCL. So BCL is a core class library and FCL having some advanced class libraries. The framework class library is a wider library that contains ASP.NET, WinForms, the XML stack, and ADO.NET and more. You could say that the FCL includes the BCL. What does it mean? FCL includes the BCLs means all the features or classes from BCLs also available in FCL. So BCL comes from MS Core Lib and system.dll. So the examples of the base class libraries are Windows Forms, which comes from system.windows.forms, ASP.NET, which comes from system.web, ADO.NET from system.data class library, WPF comes from system.windows class library. So this is the FCL classes or class libraries. So this is the system class library, which contains different classes like collections, configuration, diagnostic, input-output operations, etc. The next one is system.data, which contains classes like ADO, SQL, design, and SQL types. These classes are used to communicate with database. So the next class library is system.xml, so which contains some classes, inbuilt classes. Whenever we want to perform operations on XML file or XML data, then we need to use these classes. Then the next class library is system.web, which contains some classes related to the UI and related to the services, caching, etc. So whenever we creating web applications, we require these classes. So the next one is system.winforms. So these classes are used to develop desktop applications. It is also called as Windows applications. So the next component is base class library, which is also called as BCL. So the .NET framework are a collection of pre-built reusable classes and components that provide fundamental functionalities for developing applications. These libraries are an essential part of the .NET ecosystem and offer a wide range of functionalities, making it easier for developers to build robust and feature-rich applications. So developer need not to write each and every code for their string manipulation or datetime manipulation or to communicate with the external files. He can use existing BCL libraries like system.string, system.datetime, system.io file, and system.http client. In simple words, imagine the base class libraries is a toolbox filled with various tools. Instead of creating every tool from scratch, developer can reach into this toolbox and use pre-made tools to perform common tasks like reading and writing files, working with data, managing collections, performing networking, and much more. So let's discuss the common language runtime. So CLR, it is a major component of the .NET framework, which is also called as brain of the .NET framework. And CLR, it stands for Common Language Runtime, which manage to code execution through JIT compiler. It also performs some other tasks like memory management, debugging, garbage collection, thread support, exception handling, and code access security. So these are the major features of CLR and duties. So the CLR is not one component. It is an environment. It is a runtime environment. So any application which is developed under the .NET framework needs some kind of environment to run that application in any operating system. So similarly, we can take the examples of human beings. So to live, humans need 4 essential elements like air for breathing, water for hydration, food grown on earth for nourishment, and a healthy environment to ensure safety and well-being. So these 4 essential elements are required for humans to live and grow. So similarly, CLR is an environment and not one component. So let's check the components of the CLR. So the first component is class loader. So the next is MSIL to native compiler. So as we already discussed, MSIL is the Microsoft Intermediate Language. So the CLR will convert this MSIL to the native code with the help of JIT compiler. So the next one is code manager. The next component is garbage collector. So the garbage collector is responsible for to free the memory of the objects from the heap. Those are no longer in use. So the next one is security engine, debug engine, type checker, execution manager, thread support, COM marshaller, and class library support. So we can check each component in detail. So the first component is class loader, which manages metadata in addition to the loading and layout of the classes. So the next is MSIL to native compiler. So as we have already discussed, whenever any code from any programming language when gets compiled, then it gets converted into the MSIL, that is nothing but the Microsoft Intermediate Language. Then after that, CLR comes into the picture. So CLR will convert the MSIL into the native code with the help of just-in-time compiler. So the next component is code manager, which manages the code execution. Then the next component is garbage collector. This is the main component or main task performed by the CLR. So it provides the automation lifetime management of all of your objects. This is multiprocessor scalable garbage collector. So the next is security engine, which provides evidence-based security that is based on the origin of the code and the user. So the next is debug engine component, which allow you to debug your application and trace the execution of code. So developer can use this engine to find out the bugs from their code. So the next is type checker. So the type checker will not allow unset cast or uninitialized variables. MSIL can be verified to guarantee type safety. So the next is exception manager. As we are aware, there are compile time exceptions and runtime exceptions, which can be handled by also a CLR. So it provides the structured exception handling, which is integrated with Microsoft Windows Structured Exception Handling, which is also called as ACH. So the next task is thread support. As .NET Framework or .NET compatible language supports multi-threading, so it provides the classes and interfaces that enable multi-threaded programming. So the next one is COM marshaller, which is responsible for marshalling to and from COM objects. So the next component is .NET Framework classes. So these are the inbuilt classes which can be used while development. And these are the inbuilt classes which was provided by the .NET Framework. So the next one is library support, that is class library. So let's check the task performed by the CLR. So the first task is code execution. It provides an environment to run all the .NET programs. The code which runs under the CLR, it is also called as managed code. Managed code is a code whose execution is managed by Common Language Runtime. It gets the managed code and compilers it into a machine code. After that, the code is executed. The runtime here, that is CLR, provides automatic memory management, type safety, etc. Applications that are not under control of the CLR are also called as unmanaged code. The next task is memory management. CLR take care of allocation and releases to memory of object in heap, not in stack. But how? There is a GC component which plays a main role for this functionality. So the next task is code access security. This is a core feature of CLR. Security means preventing code execution from unauthorized access or providing security to assets from unauthorized actions through permissions by putting over code execution. Next task is debugging. This is a major feature of CLR which we use daily in our code development for testing, bug fixing, and while executing code over our local workstation. The next task is thread support. As we are aware, many programming languages support multi-threading. So thread support is also done by CLR. So the CLR provides functionality to handle the threading and multi-threading functionality for code in application. CLR thread pool determines when threads are to be added or taken away. Thread pool is just a collection of threads and thread is a path of execution. So the next task is exception handling. So as we are aware, there are compile time and runtime exceptions. Those can be handled by CLR. An exception is the signal raised when a condition is detected that was not expected in a normal execution of the program. The CLR execution engine can raise exceptions and unmanaged code can raise the exceptions as well. So let's discuss CLI, Common Language Infrastructure. Common Language Infrastructure is a standardized framework created by Microsoft that allows programs written in different programming languages to be executed in the same runtime environment. So CLI is not a component, it is an infrastructure and provides the environment for .NET application to run on any operating system. So there are different types of components of CLI: common type system, common language specification, metadata, intermediate language, and virtual execution system. So in next tutorial, we can discuss common type system and common language specification. So metadata is the additional information with the program code that describes the types, members, and references, allowing for self-describing components. So the next one is intermediate language, also known as Microsoft Intermediate Language. So as we are aware, when any .NET application runs, it will be converted into the MSIL. So EXE and DLL contains the MSIL code. So there are different types of human readable programming languages like C#, VB.NET, etc., which are compatible to .NET framework. But when that code is compiled by their respective compiler, instead of directly converting into the native code, the code would be converted into the MSIL. So it's the platform independent code that all .NET language compile to. So that is the part of CLI only. So the next one is virtual execution system, which is responsible for loading and executing the intermediate language in just-in-time compilation process, turning it into the machine code. So as we discussed, so the human readable programming languages, that is C# and VB.NET, when gets compiled, it would be converted into the MSIL, and that MSIL would be provided to just-in-time by virtual execution system to convert that MSIL into the machine readable format. That is nothing but the machine code. That is also a part of common language infrastructure. So the next one is common type system. So the common type system makes sure that different .NET languages like C# and VB.NET can understand each other by converting their data type into a common format. So the common format is nothing but the MSIL. This ensures smooth communication between them. The CTS is managed by the Common Language Runtime. Now let's see if C# and VB.NET data types can be compiled into a common base type. To check this, we will write example in both C# and VB.NET now. So one code is written in C# and the another code is written in VB.NET. So the data type is used are int and integer. So in C#, the data type is int for digit, and in VB.NET, we called it as an integer. So when code gets compiled by the compiler by the respective programming languages, so it gets converted into the int32. So in MSIL, both data types gets converted into the common type, that is nothing but the int32. So this is the C# example. So here we have taken one class which contains static void main method, and we have declared one integer variable which contains value 42, and we are just printing that value on console. So this is the VB.NET example. So in VB.NET, we are also declaring one variable number as an integer, and this is the data type, and the 42 is assigned to that particular variable. So finally, after compilation uses the same structure in 32 from CTS. A compiler is a type of software tool that translates human readable programming language code, that is C# and VB.NET, written in high-level programming languages like as C, C++, Java, into a machine-readable code that a computer central processing unit can understand and execute directly. So that is MSIL code example. When we compile the code from C# and VB.NET compiler, it gets converted into the common type, which is MSIL. So both code gets converted into this MSIL code, that is common format. So this is the high level diagram. So here we can see there are different programming languages which are compatible with the .NET framework like C# code, F# code, and Visual Basic or VB.NET. So there is, for each programming language, there is a respective compiler over there. So when compiler compile this code, gets converted into the common language intermediate code, that is also called as MSIL. Then common language runtime comes into the picture. When we execute the exe or DLL, then this MSIL code gets converted into the machine code, which can be understood by operating system with the help of JIT compiler. So common language runtime CLR use JIT compiler, which will convert common intermediate language code into the machine code. So let's discuss common language specification, which is also called as CLS. CLS is a subset of CTS. The .NET Common Language Specification CLS is a set of rules and regulations that ensures code written in different programming languages can work together seamlessly within the .NET framework. In simple terms, it's like a language translator that makes sure all languages in the .NET family understand each other. So as we are aware, there are more than 25 programming languages which supports .NET framework. So if any programming language want to become .NET compatible language, then that language should follow all the rules and regulations which is defined by the .NET framework. So if there is a C# language, F# language, and another so many languages like VB.NET as well. So each and every programming language has its own syntax and also has its own compiler. When that code compiled by the compiler, then it gets converted into the common format, that nothing but the MSI, which is also called as Microsoft Intermediate Language. How it's happened? Because all the programming languages are following those rules which was set by .NET framework. So these are the examples of programming languages: C#, F#, and VB.NET. There are more than 25 programming languages which was supported by the .NET framework. So let's have one example. Imagine you have two developers working on the same project. One developer is using C# and the another one is using Visual Basic.NET. Both are writing code for different parts of the application. So within the CLS in place, they can be confident that their code will work together without any issues. The CLS defines a common set of data types, conventions, and rules that both C# and Visual Basic.NET must follow. So in C#, let's write one class which is calculator, which contains one method, that is add, which accepting parameters a and b, and we are just returning the a plus b, that is the summation of the a and b. Suppose this class or this method VB.NET developer want to use in his code. Then this is the syntax of VB.NET. So here result is a variable of integer data type. We are just using the object of calculator class and directly calling add method and passing two parameters 5 and 10. So the CLS ensures that the data types, method names, and other elements used in the C# class are compatible with Visual Basic.NET, allowing both developers to collaborate and create a unified functional application within the .NET framework.